In this paper, we introduce a novel generative model for component-based plan synthesis. Architects need to design interior plan layout under the constraint of building outer boundary, while interior designers may also need to redesign the plans for certain purposes. Recently, AI-based methods have been proposed for these tasks. However, how to generate plans with uncertain boundaries, and how to extend the usage of plans to larger scenes are still not well addressed. Our generative model leverages the wave function collapse algorithm to merge tiny tiles into larger patterns. The wave function collapse algorithm randomly determines the eigenstate of a certain element and then tackles its neighbors. When zero eigenstate occurs, backtracking is performed to change the eigenstate of a previous tile to ensure the algorithm continues. For each pattern, two stages of networks are employed to outline the potential boundary and estimate the semantic labels of the components. We also perform the hole filling and polygon fitting to refine the generated plans and suggest the positions of the windows and doors on both the outer and inner walls of the plan. A hallucinator is employed to change the semantic labels of the plan by pre-defined groups to make variations. Hence the outdoor plans can also be generated by our method. Based on the created plan example dataset, we develop a user interface to support the plan layout design. After the user specifies a boundary input, a list of plan examples with similar configurations is retrieved from the dataset. The user can choose one to transfer its layout to the input and use the hallucinator to create more schemes of semantic labels. Furthermore, the user can choose a component of the generated plan to subdivide the space into more complex plans. Our system UI also allows users to specify the number of rooms to impact the retrieved dataset plans, thus generating a plan with a user-specified component amount. Our system employs third-order Bézier curves to input the curve boundary. After assigning 4 nodes, users can click the right mouse button to create a curve line based on such 4 nodes.
Besides, the system leverages the predefined room metrics to suggest certain modification schemes. Users can follow the suggestion to manually refine the synthesized floor plans.
Here are some 3D scenes created by the output plan. The generated plan can be used for scenes with different scales. Note the subdivided components of the large scenes. Let's see the feature space and the retrieval results of different input boundaries. The two-phase retrieval could ensure that similar floor plan examples can be explored from the dataset. Here are some examples of the plan retrieval results. The users can also specify the component amount as the input to impact the explored plan examples. Here are some plan synthesis results with hard boundary constraints. Our system also allows the inputs with curved boundaries. Using soft constraints can generate plans with different shapes that still suit the input boundaries. In these examples, we show how the hallucinatory works on the semantic labels of the plans and the corresponding 3D scenes, as well as how our subdivision workflow further designs a certain component of a plan on different scales. Thank you for watching this video.